So my name is Anshul Malhotra. I'm the founder CTO of a company called WIM Technologies. And today I will be talking about this topic here, integrating generative AI into RAN's automation software. Just a bit of background about us at WIM Technologies, just so you have a bit of context, I guess, is that we are a RAN automation software supplier. We provide automation solutions for tier one operators throughout the world, for configuration and performance management, as well as CSON, and more recently with the whole sort of advent of ORAN, with the RIC as well. So we've been around for almost a decade now, and we're mainly a traditional software vendor. And I guess what we're focusing now is integrating AI into our current software stack, as is with a lot of software vendors. Currently with all the stuff going on with ChatGPT and generative AI stuff. So basically, the presentation, I guess I'll focus on how a telco software vendor like ourselves can integrate generative AI technologies into our existing platform incrementally to deliver some value to telecom opcos. I want to talk a little bit about the history of AI telecoms, or AI in telecom, really. Basically, obviously starting off with the early 2000s when with the sort of, initial sort of GSM and 3G networks, a lot of the sort of code base was around sort of rule-based automation within network management, I guess. There was very little sort of true machine learning and AI and stuff, sort of pre-AI days, which then kind of moved on a little bit with with self-organizing networks, with the sort of 3GPP specification leading the way with SON and so on. There was obviously some more automation that was added within networks. There were some automation use cases like adjusting antenna tilts and power based on detected coverage issues, on network performance metrics. All of that sort of, had some sort of basic ML that was introduced in those days. Then, of course, moved on to sort of big data, came around, big data analytics and so on, with sort of the explosion of mobile traffic on 4G networks. Operators began leveraging big data analytics. There was sort of, bit of ML AI systems with traffic-based network traffic predictions and so on that would use sort of historical data and predict network traffic peaks and stuff. And then again, now with sort of 5G coming along in the early 2019, 2018, 2020 sort of a thing, where a bit more sort of AI-driven 5G networks with sort of network slicing coming around, and dynamic spectrum management. AI models are employed to dynamically manage and share spectrum resources between 4G and 5G. There's a bit of sort of deep learning for predictive maintenance as well, that's sort of happening, as well as real-time RAN optimization. And then the more sort of recent initiatives are driven through ORAN, I guess, with the ORAN specification, making it quite integral to how network automation needs to run with the RAN intelligent controller, real-time, non-real-time, etc., which really have sort of AI ML built into these RICs as they are, as per the specifications, so that a lot of the non-real-time or the real-time functionality can be implemented through machine learning algorithms. And finally, I guess with the with more the generative AI stuff with ChatGPT, I guess that's where I guess a lot of the focus has now shifted to human-led issues, not resolved previous areas of automation, which Gen AI is able to hopefully solve. So I guess today my focus within the next sort of 15-20 minutes that we have is around just talking around generative AI and basically focusing on a couple of use cases that we have started with in our endeavor to build something quite large scale in the future, but obviously baby steps, demonstrating perhaps a couple of good cases that we have implemented within our software as well. let's see. So, of course, like I said, there's a massive hype about Gen AI, and I guess from a radio access network point of view, that's where we basically, play in that kind of domain. There is a massive amount of complexity in the network now. There's thousands of parameters that control the behavior of the network. Each parameter affects multiple aspects of network performance. There's obviously high interdependency between parameters, which make changes risky. Essentially, there is a lot of performance counters that you get from the network as well. So, each parameter that you change or configure in your network will have some impact on a performance counter. So it's really, really tricky to try and, build a autonomous sort of system which will allow you to, literally, take care of your entire network. You literally have to trial and error learning process where, change a parameter and see the impact of that change in your network. You might change many parameters which may have interdependency. So in order to learn from that, it is really, really difficult and really tricky. And even though there's a lot of pressure in trying to kind of come up with, there's ChatGPT, generative AI, that's all over the place, and there's obviously more pressure on organizations like us to incorporate, more and more of it in order to kind of get to this, zero touch autonomous network management. But it is very, very difficult to kind of get there if that's your initial goal. So what our approach has been is to focus on solving incremental issues. So really, on the focus on niche areas. So we've identified some key niche areas that we are applying generative AI in. So we've got obviously a big sort of software suite which works on optimization, deployment, CSON, RIC, automation, field services, and all that kind of stuff. So and we can't necessarily bring them all together from day one. So what we've kind of looked at is, target some niche areas, some niche problem areas, which I'm going to discuss further, where we can literally use AI as a supplementary tool, rather than, looking at replacing the radio engineers. Essentially, at this point, we are really focusing on providing the radio engineer with a tool that they can essentially utilize to better manage their network through the use of generative AI. This is sort of our mission statement, really. Each vendor who wants to sort of go around doing this, in my opinion, would have to have a final goal in mind. And in our case, we basically looked at improving, time to visit. So basically, we want to develop an AI solution that interacts directly with the network, enabling seamless navigation within applications. So what that means is that that the AI within our platform one day should be able to, make API requests and, display relevant information within a tool by switching tabs and making, different changes and implementing, perhaps changes in the network by utilizing our platform, so to speak. And this approach is to develop a more sort of intuitive, user interface, and making it such that the role of the network engineer would basically change to more of a automation engineer. So they would spend more time training the AI model to solve the network issues and problems that they see in the network, as opposed to kind of looking at it as well. The radio engineer's role will be replaced one day using generative AI and so on. So on the right hand side, it's just a little interface that we've kind of created, which I'll talk through shortly in the presentation. Bearing that in mind, I guess we had a bunch of objectives. So within a sort of radio network, there's three key areas that you've got to focus on. You've got a problem, you've got to identify what the problem is. You've got some kind of root cause analysis that you've got to conduct, and then you've got to have some kind of an implementation engine which would then implement changes in the network, whether that might be by running some commands into the network and changing some configuration, or whether that might be changing the tilt of an antenna, or that might be sending a work order so somebody can go in and change something on the site which can't be done remotely, for instance. So what our first sort of two use cases that we've kind of looked at is mainly around root cause analysis. So we've built, two initial sort of AI solutions. One is around, AI help engine, and this is something that is kind of being done all over the industry, to be honest. A lot of sort of websites which traditionally would have, bots that you could engage with now essentially have, ChatGPT powered bots where you can type in information about, what you're looking for, and they will, give you, a human-like response back, so you can have a conversation around, some issue that you may have, and so on and so forth. And what we've done is essentially done something similar, where we've actually given the generative AI model a whole lot of documentation, which includes user guides, presentation, design documentation, release notes, and all kinds of other collateral that we've had over the years, and made it sort of learn our tool set, so as to be a little bit more engaging. So traditionally, where you've got a software tool, you've got some help files you can go in and ask for, how do I do this, how do I do that? More sort of statically. Here you've got a more conversational way of sort of saying, well, if you can see this screenshot, it says, how can Unison help me with my LTE network interference? We struggle with large DCR in some areas. Give me a short description. So what the generative AI would do is, in the context of what we've taught it, it would come up with, well, you can do this in order, you can basically use Unison's AIM, which is our automatic interference management system platform, which allows you to change PCIs and RSIs within the network. And it basically, guides them to say, well, this is one way for you to solve the problem. So it's kind of a bit more targeted. So you've got a problem and you've got the solution that helps you with the problem, but the AI help engine is sort of assisting you a little bit more by giving you a little bit more information, which you can be a bit more interactive with, and then utilize certain aspects of the tool to solve the problem, and so on. The second use case that we built is essentially AI query assistant. So this is where it's almost like an English language to SQL translator, so to speak. So you can then, of course, we've got a fairly sophisticated sort of SQL database that the application connects to and writes into, and so on. A lot of data gets read into it. And what we've done is we've exposed the schema of that database back into the generative AI. So just the schema, no sort of specific data. And what you can then do is you can ask questions to say, well, I'd like to query this, that, and the other data, and it will then come back with a SQL statement, which you can then utilize to do further analytics on the tool. So you might ask a question, which is what I've got a little demo, a video demo for a couple of minutes, which will showcase somebody asking a question to solve a specific problem in the network, and it comes back with a bunch of queries, and you can then run the query and see what the what the issue is. So again, very sort of conversational in nature. You ask a question, it's trained on our model and on our database, and it would then answer that with a query, etc. Where we're going with all this, I guess, is sort of, like I said, it's sort of, kind of think about it as building a staircase. So it's just a couple of stairs to our eventual goal. Like I said in my previous slide, is that, by teaching the generative AI about essentially, how the tool functions, and, and kind of connecting that with the real world sort of information it has about networks and about technology, really. We're making the generative AI learn more about what kind of how to solve certain problems as these problems arise, and the user interacts with it. And this one is more around the root cause analysis, where we wanted to then learn from the problem statement, and then generating a piece of code to solve that problem in a more sort of real world scenario, and so on, right? So again, these are kind of like our building blocks, and then on top of it, we will kind of carry on making sure that it understands more and more about our technology, our platform, our framework, as well as the actual technology is trying to solve, and start giving out quite yeah, using the LLM really to kind of give out really, really good sort of targeted, root cause analysis within this framework. Talk about a little bit about the R&D journey. So broken that down into a few things. So technology, process initialization, AI model configuration, and challenges. So we, of course, looked at a bunch of technology, ChatGPT, Gemini from Google, Meta AI, and did a bit of analysis to see which technology suited us best, which is something that most vendors would want to do. We chose OpenAI, ChatGPT, because at the time when we started doing this initiative, it was probably the most mature one, as well as the fact that it's got a very intuitive API playground set up. It's fairly straightforward. Give it a name, give it some instruction, give it choose a base model, add some files to it, and then you let it, you're sort of almost ready to go. You also have a whole bunch of different, configurations, temperature, max response token, etc. It's a way to kind of contextualize the data that you give it within ChatGPT. I mean, a lot of you might be sort of already aware of the fact that you ask ChatGPT questions and it starts giving you sort of false information or it makes things up. So it's really trying to control that to hit the sweet spot between what you are giving it and what it must make up, sort of a thing, so that it contextualizes all the information that you give them. So those parameters are important for one to understand. However, you quite easily run into certain challenges. Now, ChatGPT is really, really good because it gives you it has a lot of information on the internet that's been trained on. Now, organization like ours and even sort of largest organizations, we don't have a lot of collateral. We have documentation, we've got user guides and so on. However, those are very sort of human consumable, and humans can sort of look at stuff and sort of contextualize things much easier. Whereas what we found was that we'd give it information and it wouldn't necessarily be able to provide us with the answer, because we have to make the information a lot more granular. So the limited data source essentially has a few challenges which one needs to kind of work towards, and building up a repository of comprehensive information obviously requires a lot of time and effort, and that's essentially what you need to continuously do in order to improve the model. And one of the things that we had to do is essentially, as we have conversations with it, we save those same conversations, then in a feedback loop gets sort of fed in back into the generative AI in order for it to continuously train it. So it's quite a complicated, not complicated, but perhaps a tedious process that one has to go through in order to, train it. So where this line says leave the rest in default and you are ready to go, is not quite true. It's essentially that's the first step, and after that you've got to still do a hell of a lot of work in order to get it to get better and better in time. Okay, so this is just a quick video demonstration of what the one of the use cases that I discussed above. I've got a query assistant here. You can basically write a problem statement here. In this case, we've just said, please generate a query to identify distance-based PCI conflicts in the network. This causes interference, for instance. And then, it kind of analyzes it because it has all the relevant database information. It automatically then comes up with a really, complex SQL statement. User looks at the SQL statement, says, "Oh no, I need a bit more information." So it says, "Okay, well, I need source and target status columns." It would basically then say, "Okay, I need to do that." It will then generate source and target status, or add source and target status columns in there. It would then, generate the query again, say, okay, I want to filter it further, add London as a region to it. It will then look at that, generate another query to add the additional filter in there. So there's a where clause in here, which basically says London in there. And then you can sort of click on it to see some results. Now, this is sort of a test. You can see, okay, well, it returns 10 results. Okay, I look at the results and maybe I'm not happy with it. I can say, okay, well, in this case, I noticed that I need to sanitize this data. I noticed that these two columns are 0, so I want to exclude those from the data results. It will then obviously come back, you give it another instruction, then generates you the final output, hopefully, of the SQL, and then you can run that and it would give you the entire bit of information, final 2000 results that identify a network issue. So now you can obviously take this information and then, of course, focus on it to fix whatever you need to do. In this case, you probably have to do some replanning in the network, and away you go. So really, in a fairly, just leveraging the power of ChatGPT, just going conversationally, being able to start a conversation with asking a problem statement and then working your way through it. You've basically been able to quite quickly, find a resolution to a problem that you have in the network. Okay. So I think we're almost 20 minutes, which is my time. In summary, I guess, a couple of things to mind here would be identify Gen AI target areas. So, there's obviously, like I mentioned, there's a evolution of automation, AI and telcos. There's still many manual processes. So, obviously focusing on those niche processes, small processes that will add incremental value is what one can focus on from a generative AI point of view right now. Incremental learning, AI needs to provide flexibility to iteratively learn. So, by creating these small components, intention is to then build the whole sort of staircase, as I mentioned before, and that's kind of important to continuously give value to the end customer, and assist and improve. So the idea should not be to sort of replace the engineer. It's to essentially the role of the engineer would evolve from fixing problems to becoming more of an automation engineer within our field. And I think that's kind of where the focus needs to be, is to assist and improve, more than sort of replacing an engineer, I guess. And that's that really. I think 2 minutes over time.
Okay, we have a question, please, Anshul. Very interesting presentation. We have a question from our audience. Mihaela says, could you provide an overview of the cost savings you anticipate from implementing generative AI, both generally and within the specific niche areas you've explored? Additionally, do you have any concrete figures to support these projections? What I'm thinking, actually, possibly, Anshul, especially given we're nearly out. Well, I think we've got a few minutes, but is that something you want to tackle at the moment?
It's kind of hard to tackle because it's got a big sort of an area to cover, to be honest.
Oh yeah, it just seems to be something that could requires a lot of information.
Yes, yeah. I mean, I'm more than happy to answer it over email if time is of a concern, I guess.
Well, yeah, I think that might be the best thing. So in that case, Anshul, if you're willing to do that, please. We've also got another question, that is, do you build from scratch or do you build some basic framework, or do you use a basic framework to build the AI?
Well, you basically build from scratch, really, because I mean, scratch being that you've got OpenAI or the APIs that you currently have. You basically then build the model essentially from ground up. In our case, I guess we have a platform that we built, so it's really just sort of integrating it. So there's a whole lot of code base that allows the user to do different things and so on and so forth, like the GUI that I showed you. But the actual model creation and training and so on, that essentially is done from the ground up.
One other question I have for you: there's been a lot of publicity around the huge slowdown in building out the RAN, and particularly Open RAN seems to have almost ground to a halt for a whole load of reasons. But I'm just wondering what your experience in the market is. How are operators reacting to the possibility of deploying AI in the RAN? Are they enthusiastic because it makes more of what they've got already, or they don't want to spend the money, or I don't know?
Well, it's a multitude of factors, to be honest. I mean, the thing is, as much as operators like to want to introduce something like AI within their networks, it's still, there's still a lot of basic problems to tackle. Data is always an issue. Trying to get, clean data has been a problem in, a lot of networks that we go work in. And unfortunately, until you have clean data, or like we try to call it, a single source of truth, you don't necessarily have, you can't do much with it until that data is clean. So, we kind of have a bit of a stepwise approach to kind of saying, well, clean your data, implement your design, add some automation before you can get to the big bad world of AI. But saying all of that, though, I mean, that's one of the key things that I was sort of saying earlier is that, focus on trying to solve smaller problems. So if you can solve a niche problem within an opco, that can add quite a bit of sort of business benefit. And there's certain areas that you can add that to it, but you can't just sort of say, well, I'm trying to make a zero-touch autonomous network from the beginning. I can look at a certain problem in an opco, mobile operator, and solve that problem, without actually having to worry about all the other things around it. So really sort of almost like bite-sized, problem-solving AI is what I believe is the way to go currently, until such time that, networks are mature enough. There's a lot of stuff happening, like you're saying, Open RAN is in there. You've got traditional RAN. How does that interact with each other? Data sanitization is a problem. So until some of these things are a little bit more mature, I don't see networks being fully automated, if that's the nirvana.
Well, I mean, it was interesting that our keynote speaker yesterday, Philippe Ansargay from Orange, was just talking about how important the data layer is for visibility.
Right.
And that really, if you want to deploy generative AI at scale, as opposed to in pockets, then you've got to go through those layers to build on. You can't just leapfrog. There's no way around it. And considering how long we've been talking about big data and data lakes and data management, I think really still it's a very messy area for operators, because they just have so much data and it's so hard to deal with.
Exactly. I think we see that all the time. There's just, and I touched on one of the slides, is that there is a lot of data in the network. So even if you've sanitized the data, there's still a lot of data which influences each other, and there's interdependencies, and trying to apply AI to it would require a lot of trial and error, and that's very risky. You've got a live network running. You're not going to, change things in the network just so that your AI can learn from it. But there are techniques that one can obviously use to do that. So what we tend to sort of do from time to time is that, operators are using our platform to solve a certain problem, make changes in the network. So what we do is we look at those changes, we measure the results of those changes, and we try and feed that back into a machine learning algorithm to say, well, if this changed and this was the impact of it, learn from it. And then, slowly kind of keep building up a repository so that you can then say, the machine can start doing some of those things that the humans are currently busy with, right? So, so you can use that approach in order to, simulate the trial and error, because, a human's making a change and you're learning from it. But, if at scale you had to kind of go, well, I've got 1,000 parameters that I need to change in the network, and look at what the influence or impact of those 1,000 parameters is in the network, it's very, very difficult to, or very risky for a machine to kind of do that and then simulate it and then get the answers back. So yeah, it's trying to do it at scale is very, very hard at this point in time.
Thank you, Anshul. I tell you what I always think about with AI. There was children's books, I think, by Lemony Snicket, that was all about unintended consequences.
Right.
And that's what I always think about, because the situation can become so complex, and the sequence, and I think it's impossible to predict really in certain situations what could happen. Interesting though.
Yeah, it is interesting, I think. Yeah. Interesting times anyway.
It certainly is. That was a really insightful presentation, Anshul. Thank you very much indeed.